All right, so find the volume of the region between rho equals cosine phi and rho equals 2. So, as usual, numero uno is figure out what the heck this region is. So let's see. So the first part, or the first thing rather that I see is that the second equation is going to be a sphere of radius 2. So no big whoop there. For the rho equals cosine phi part, it's tricky. At first blush, you go, I don't even know what to do with that. Then you want to start thinking about the coordinate functions that you know. So x equals rho sine phi cos theta, y equals rho sine phi sine theta, z equals rho cosine phi, and say, okay, how can I see anything related to this stuff over in this one? And maybe you notice that this one is not too far off. The only problem is that it's got a rho, and this doesn't have a rho. But I can amend that by multiplying both sides by rho squared. Okay, and so now it's easy to translate into Cartesian. The left side is x squared plus y squared plus z squared, and the right side is just z. And so now, as we just saw in the previous review exercise number 5, this one is going to be z minus 1/2 squared equals 1/4. So what do we have for the figure here? As seen from the side, we've got something that looks like, let's see, on the one hand we've got a circle of radius 2, and let's see, dial that in a little bit there. And then on the other hand, we've got a circle of radius 1/2 centered at 1/2 on the vertical axis. So something that looks like this. All right, so it's like the Death Star, except not really a Death Star because that's actually a hollow gap in the center. Okay, so how are we going to set this thing up? Well, if we think about spherical or radial lines coming out, these ones are, anything coming into the top half is going to begin at this sphere and then extend further. Anything in the bottom half is going to contain the origin, and it's going to go all the way just straight out. So that one's kind of easy. But this is not an elementary region for spherical coordinates. Okay, so we will have the top, and so this is going to be where we're going to go. So theta is going to be all the way around because it's rotationally symmetric. And then phi, this is going to be for the top part. So this is from 0 to pi over 2. And then we need to go from rho equals mini sphere. All right, so that's cosine phi, up to rho equals big sphere. So that's rho equals 2. And then we've got our volume element, rho squared sine phi, d rho, d phi, d theta. And then we're going to add to that the bottom. So that's going to be 0 to 2 pi, 0 to, sorry, this is the bottom. So now we're going from pi over 2 to pi. And then we've got from 0 to 2 rho squared sine phi, d rho, d phi, d theta. Okay, and so this is, maybe I should move my labels here. So this is the top, and this is the bottom. Okay, and now we have to evaluate the integral, or do we? If I gave you this on an exam and you were able to figure out what the region is and then say, oh, so you know what this is? This is going to be the volume of the big sphere minus the volume of the small sphere. So that's 4/3 pi r cubed minus 4/3 pi r cubed is equal to, so 21 over, wait, did I do that right? No, hold on. Let me step through the math there. So we've got 8 minus 1/8. So that's going to be 63 over 8. This is a side calculation now. I got sidetracked in doing stupid arithmetic. So I got 63 over 8. And then multiply that by 4/3. So that's going to be 2, and 63 divided by 3 is 7 times 3, 21. Oh, what the heck? I had it right. Okay, 21. So 21 over 2 times pi. Bam. And that's fully 100% legit. Coming up with nice shortcuts is a good thing to do. Don't waste time, save labor.